All right, hello once again. Jeff Scott of Rankin Technical College. And yesterday, the 6th of January, 2020, was the first day of class. And I did 3.5 Java programs. And I've got the first 3 that I worked on are on the first 2 videos in this series. Unfortunately, when I went to do the third one, either I forgot to turn the recorder on or there was a glitch. I don't know what. But what I want to do is first I want to come back to the third one that I did because I'm not sure if the run that I did is actually on here or not. So what I'm going to do, first I'm prettying it up, which of course is totally unnecessary, but looks a little nicer. So this was the one where we used the J option pane, both the show input dialog to get our inputs, and then we threw everything into a string and did a show message dialog on it. Okay, so let me do a file save all, and then let me run this. Like I said, you might already have seen this. You may not have. I don't know. So here it comes up, put in your first name, Jeff, middle initial P, last name Scott, age 63, union status false, employee number 1, 2, 3, 4, 5, hours worked 40, hourly rate 10, and it's got all of my information. Okay, just wanted to show you that. Now, what I did for the rest of the period was I started on the next iteration of this payroll program. It is 5:40 in the morning, and I don't feel like retyping this. So I'm going to go over it, leave it up here, really take my time, spend about a half an hour right here, go over literally every single line in this program thus far. And I'm going to finish the program up today. All right, so I start by in lines 1 and 2 doing my import statements. Again, these import statements are going to allow me to use built-in Java code from the Java API or Application Program Interface. The first one is Java text, and it is the decimal format class. You'll notice if you look down here, I'm creating 2 decimal formats. One has a $sign, one does not, but they're the same size. They both will hold a number up to, but not, or up to $999,999,999.99. Now, I'll never have a payroll that big, but I'm just making it nice and huge anyway. So again, these 2 patterns are identical to one another, except for the fact that the first one has a $sign, the second one doesn't. The pound signs in here means show a number if that number is not 0, but if that number is 0, in other words, if it doesn't exist, let's say that somebody made $1,234.12. That'll print as $1,234.12. So that'll print like that. On this example here, if they made the same amount, it'll print the same way, except it won't show the $sign. Now, those zeros that are by, the last 3 digits, this means that if for some reason, let's just say the person made nothing that week, this one will print as $0.00, and the other one will print as 0.00. Okay? So the pound sign says print a digit if there is one. The 0 means even if there isn't one, at least show a leading 0 and zeros representing the cents figure. The ability to do that is what's given to me in that particular library. The other one that I'm coming in here and I'm actually doing an import on is this JavaX swing J option pane. Okay, now I did talk about this. Again, I'm not sure exactly what lecture it was, But back in the quote olden days, unquote, I'd say probably around 30 years ago when Java was conceived, the idea, the mantra, so to speak, behind Java was write once, run everywhere. In other words, I could write myself a Java program for the machine I'm on right here, okay, and compile it, run it, then take the same program over to a mainframe. I probably would have to recompile it, but I'd probably have to make no changes to it whatsoever, and I could just run it. Now that's all fine in theory. The problem that you get with this, the problem that you get is basically between like Windows and Apple. And what I mean is the way that Windows shows a button and the way that Apple shows a button are not the same. They look different, actually pretty markedly different. So what happened was the people who, I believe, who created the language went back and tried to do a bunch of redevelopment work to make sure that these looked more the same than they had looked. To do that, they created a new class called Swing that, whereas there is, for example, a Java dot like label or something like that, there is now a JavaX dot swing dot JLabel. So the idea behind these Swing components is, first, they're designed to look even more alike amongst different types of machines. So whether it's a mainframe, a mid-range, a PC, a Linux box, an Apple machine, etc. Okay, and the actual non-Swing components, the labels and buttons, etc., were kind of heavy. And what I mean is they were known as heavyweight components. They a lot of times took up more memory than they probably needed to, whereas the Swing components are more lightweight. All right, so that was long, but you got it at least. So this is our fourth iteration of a payroll class. All right, we started here by making some constants, about 9 constants if I counted right. So we've got, you've seen these before, max non-OT, which is 40. That's the most hours you can work in a week without getting overtime. The overtime rate, which is time and a half. The minimum age for somebody working at the company. These are arbitrary values. I just came up with 18. Originally here, I had put 130. Notice when I do that, I get an error, because the maximum size for a byte is 127. Whoops. See that? Now it works. So I just cut it down and made it 125. The minimum hours somebody can work are 0. They're sick, they're on vacation, they're whatever. The maximum number of hours somebody can work are 84. That's 7 days a week, 12 hours a day. So I thought that at least made sense. The minimum pay rate for somebody is 0.0. All right. And again, maybe they're a volunteer. I don't know. The maximum rate, and again, just an arbitrary value, is $100. And we will have 5 employees. So how do I know that these are constants? Not because I put a comment there that said constant. No. Because they all have final before them. Final pretty much takes the place of const that we used with C#. Private allowed me to bring in the fact that these are private, so they're only directly known inside of this class. Static, for lack of better words, for now, static means there's one of these. So no matter how many payroll objects I would create, they would all share these variables, which makes sense. The minimum age should be 18, regardless of how many employees I create. The maximum age, 125, maximum rate, $100, etc. Now you'll notice that some of these are gray, which means they have not been used yet. Some of them are not gray, which means they have been used. All right? So not only do I have 9 private constants, I have 3 private variables. I'm going to have the total gross pay for all my employees. And as shown earlier, these are my 2 decimal formats. I'm not going to go over those again. We've already talked about those earlier. Now what I did in this iteration of the program, if you look in here, and I could probably squeeze this whole thing in here. There we go. One more time. Come on. There we go. I know that's small. Well, let's make it bigger anyway. Main, the first thing we're doing in here is we're creating, these are local variables, 1, 2, 3, 4, 5, 6, 7, 8, 9 local variables. One representing each employee's first name, each employee's middle initial, each employee's last name, each employee's age, each employee's union status, each employee's employee number, each employee's hours worked, each employee's hourly rate, and each employee's gross pay. Now, I know that was redundant for me to say all that, but hopefully that totally makes sense now. You'll notice that right now all of these, all right, are in here. Don't worry about them being gray or not gray, but they're all going to be used in here. Now, notice, again, I did not have a chance to finish. Actually, I could have finished yesterday. I chose not to. It was a little bit of an exhausting period. All right, so we got to a certain point and we stopped. Main is going to be a driver now. After we declare these 9 variables, we're going to use a for loop. And we're going to input each of our pieces of data. The employee first name, the employee middle initial, the employee last name, the employee age, the employee union status, the employee number, the employee hours worked, the employee hourly rate. So those 1, 2, 3, 4, 5, 6, 7, 8 pieces of data. Then we're going to calculate the gross pay, all right? And we'll even put some overtime, etc. in here. Then after we get done, we'll display the information for each employee. In other words, each employee's first name, middle initial, last name, age, union status, number, hours worked, hourly rate, and gross pay. And we'll do this 5 times. The only ones that I finished are the ones that are not commented out. So I've done these first 4. I'm going to pick it up here in class this afternoon. Now these look similar but not identical to what we did before because I've added a little bit of validation to this. So FN is first name. I could have called it anything. So I'm creating a local string called FN that I'm going to pass back. Originally that string has nothing in it. So I go in and I ask the employee, or I ask that the employee's first name be entered. Then no matter what's entered, I trim it, which just like we learned in JavaScript, is going to remove any leading zeros and any trailing zeros. And then I check and I say, okay, now I've inputted something and I've trimmed it. If it is equal to the empty string, meaning if there's nothing in it, so if it's equal to the empty string, I'm just going to do it again. So by the time I reach this line right here, I can be assured there is something in there. And that something that's in there is not just hitting the space bar. Because if I hit the space bar, the trim on line 61 is going to remove that space. Remember, the trim removes any leading or trailing spaces. If the first name of the person, let's just say, was like, don't know why this, but it just came and popped into my head, Juan Pierre, Juan space Pierre, that space that's in between Juan and Pierre would not be removed. Only leading spaces before Juan or trailing spaces after Pierre would be removed. So again, I'm doing some data validation. You'll notice that when we do the equals, now Java has changed a little bit over the years, but at least it used to be, and I'm going to just put an example here, so I'm going to put some code right here that I'm going to put in as a comment, and then I'll remove it. It used to be if I did this. So I'm going to have 2 first names. First one, And I'm going to set that equal to Jeff. All right. Then I'm going to have first two, which I'm also going to set equal to Jeff. All right. It at least used to be, if I said if first one equal first two, that actually would have come up as false. Because what these two things say are first one and first two, are they both pointing to the same variable? And as you can tell looking in here, no, they're not. They're not pointing to the same variable. What do I mean by that? Well, what I mean is literally when I create this variable somewhere out in memory, let's just pretend for a second, at memory address 1000, starting at memory address 1000, all right, that I will have, it won't be in there J, then E, then F, then F. It'll be the machine language representation, or zeros and ones that represent J, E, F, F. On the other hand, when I do this one, it'll be at someplace else in memory. Maybe at 8765. I'll have the J and the E and the F and the F. So the system will check here and say, are both of these pointing to the same area in memory? They are not. So when you are working with strings in Java and you want to check for equality, do not use equal equal. Rather, as I'm showing you right here, use the dot equals. So it's the first one, Fn, dot equals, and then what you want to measure it against. So in the example I showed you before, it would have been more like while first one dot equals first two. Okay? It would have been something that looked like that, not equal equal. So it would have been that and not that. All right? Okay, so that's the first one. Once we put that in, eventually we'll get down to line 64, so we'll return something. Now, all this is checking. The only thing that this is checking is what we put in there, something that's non space. Is there something in there? If I put 23 in there, it thinks the first name is 23. Okay, I'm not checking. I'm not using regular expressions, for example, to check to see if it's only letters, let's say. All right, so that did this one. Next, we input the middle initial. Pretty much the same thing. If I cut this down so you can see all of it, you'll notice it's almost the same routine. Instead of FN, we used MI for middle initial. MI instead of FN. We're telling the message is different. Input the middle initial. We're trimming the middle initial, and we're doing it while the middle initial is not blank. And when we get there and have it where we want it, then we return the middle initial. All right. Again, the last name, just as the other two that we've seen, is again almost identical. All right, almost identical to what we've done so far. So again, the input first name and the input last name, let's talk about what's different. One is called input first name, one is called input last name. This is just a local variable. So for all three of these, if I wanted to, I could have used FN here, and then also here, and then also here, if I wanted to. Those would be three different variables named FN. They would all be local or known only to the method in which they're defined. Remember, a method is a function inside of a class. Since we're working with classes now, these are all methods. So what else is different? They've all, the name is different. One says FN, one says LN, one says MI. Here, here, and here. Then the input dialog, one says input employee first name, one says input employee middle initial, one says input employee last name. Then we trim each one of them and check to see if they're equal to the empty string. In all cases, if any of them are equal to the empty string, we go back and do it again. I used to do while here. Earlier, we'd used a for. And I believe in the next routine, which is input the employee age, we'll use a while. So like C# that we looked at before, this language supports, this language supports a for loop, a while loop, and a do while loop. So the last routine that we did yesterday, notice we're up to age. After that, there is no more. So the reason that I went back and commented these out, if I uncomment these, I'm going to get error messages because these have not been written yet. I did not yet write input emp is union, input emp number, input emp hours worked, input emp hourly rate, calculate gross pay, and display all. This returns a string which gets put in there, returns a string which gets put in there, returns a string which gets put in there, returns a byte which gets put in there, returns a boolean which gets put in there, returns a string which gets put in there. These three each return a double which gets put in there, there, or there. This doesn't return anything, so its return type will be void. So return type string, 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 byte, boolean, string, double, 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 void. All right. But again, I have not yet written these routines, which is why for now they're commented out. And again, I will start class today by going over those and writing those routines. So let's look at the last one here, which is the age. The whole thing is right there on your screen. You'll notice that each one of these routines is public, which means it's legal to call those from someplace else, from another class, for example. They're each static, and one of the reasons that they're static is they all are called directly from main, which is a static method. Notice if I come back, I'll go right to the one we're at right now, which is the input the age. If I remove static, and I come down here, at least I thought I was going to get an error message. Maybe I don't, but I thought I was going to. I thought yesterday when I did this, I did. This routine will return a byte, that's age, and it's called input employee age. Now remember, we went through this in the last example that we did. We came up with an input dialog that said input age. This time I'm being more descriptive. Never hurts to be descriptive and to assume that the person who is going to end up running your program has little to no knowledge of what they're supposed to do. So this will say input an employee age between 18 and 125. But remember, let's say I put 63 in there. It's not the number 63. It's the string 63. So I have to convert that over. I have to convert that over to a byte. And that's what I'm doing there. And again, we've looked at not parse byte much before, not before before today, but we did do a parse int and a parse float when we were working in the JavaScript class, AWD1000. This is very similar in nature as far as what we're doing. Then here's a while loop. So while the age is less than 18 or the age is greater than 125, we just ask you to do it again. So these two lines, 105, 106, 107, or 3 lines, are the same as these lines right here, except since, remember, this is both declaring the variable right there and initializing the variable right there, declaring the variable right there, and initializing the variable right there. Since we've declared input string in line 99, and since we've declared age in 101, we don't redeclare them. So this is a declare and initialization. This is a declare and initialization. These are just declarative statements. So once I get here, I should have an age that's between 18 and 125. All right. So when I run this, hopefully, 5 times it's going to ask me for a first name, then a middle initial, then a last name, then an age. Then a first name, then a middle initial, then a last name, then an age. 5 times. Let's see if that works. So I'm going to do a file save all. It's been a while. And I'm going to come in here and then run this. So there's my first one. Jeff P. Scott 63. So that should be employee 1. All right. Sandy K. Scott 63. Taylor F. Scott 29. Mackenzie M. Scott 28. Chloe J. Scott 23. Whoa, and it's not. I thought I put in 5. Let's try one more just to make sure. Jeff P. Scott. Well, it looked like it gave me 6. So that means my for loop is wrong. It shouldn't be less than or equal to. It should be less than. Okay? No biggie. We'll make that change today. So when class starts today, I'm going to write these routines. Input emp is union, input emp number, input emp hours worked, input emp hourly rate. All right? Then we're going to write the calculate routine, and again, we will put some logic in there. We will use the variables. I don't know why that keeps happening, but it does. We will use the variables up here, the max, non-OT, etc. Again, these are gray because they have not yet been used. Then we will write our display all routine. After we get done with that, we're going to step back and we're going to start to talk about what makes a program a Java program, so to speak. And we're going to do another iteration of this, but it's going to be simpler. What I mean is every employee is going to have a first name, a last name, like a number, I think, an hours worked and an hourly rate. That'll be it. And then we will fold that back into here and make a bigger program. All right, so that's pretty much where I left off. Okay, and you now have 3 complete Java programs and a 4th partial program that we will finish up today. All right, so that's it for, at least for right now. That is it. Like I said, this keeps going nuts, and I don't know why, but it is anyway. Okay, so that's it till the class period today.